Module 3, Geometry and Measurement. Question 1. A stove has one circular burner. This burner has a radius of 11 centimeters. The question is asking for the area of the top of this burner in square centimeters. We know that the area of the circle equals pi r squared equals pi times 11 squared equals 380.13 centimeters squared. So the answer we are after is option D. Question 2. The length and width of a rectangular photograph were increased by a linear scale factor of k equals 4. The question is asking by what factor the area of this photograph has increased. We know that the area of the small rectangle is length times width. We know that the length of the large rectangle is 4L and its width is 4W. So the area of the large rectangle equals 4L times 4W, which is 16L times W. That means that the area of the larger rectangle equals 16 times the area of the small rectangle. So the answer we are after is option D. Question 3. A rectangular swimming pool is enclosed by a brick wall on one side and a fence along the other 3 sides. The pool is 8 meters long and 5 meters wide. The fence is 1.2 meters from the pool on each side. The area between the pool and the fence will be concreted as shown shaded in the diagram below. The question is asking to calculate the total area that will be concreted in square meters. The area to be concreted is equal to the area of the outside rectangle minus the area of the pool. The length of the outside rectangle is 8 plus 2 times 1.2, which is 10.4 meters. The width of this rectangle is 5 plus 1.2, which is 6.2 meters. Therefore, the area to be concreted is equal to 10.4 times 6.2 minus 8 times 5 equals 24.48 square meters. So the answer we are after is option B. Question 4. Points A, B, and C are located around the lake as shown in the diagram below. Point A is directly north of point B. Point C is 46 meters from point A on a bearing of 133 degrees. Point C is 35 meters from point B on a bearing of 074 degrees. The shortest distance from point A to point B in meters can be found by evaluating which one of the following expressions. We are going to use the sine rule, which is AB over sine angle ACB equals BC over sine angle BAC equals AC over sine angle ABC. We are going to substitute the values we know. We know that BC is 35 and AC is 46. We also know that angle ABC is 74 degrees. We can calculate angle BAC, which is 180 degrees minus 133 degrees, that is 47 degrees. Also, we can calculate angle ACB, which is 180 degrees minus 74 degrees minus 47 degrees equals 59 degrees. Using the first two fractions, we can write that AB equals 35 times sine 59 degrees divided by sine 47 degrees. So the answer we're after is option A. Question 5. A square-based pyramid is shown below. The question is asking to calculate the height h in centimeters of this pyramid. We can put h in a right-angled triangle as shown, ABC, and the base is half of the side of the square, which is 7.5 centimeters. We need to calculate the hypotenuse of the green triangle. Therefore, we are going to construct another right-angled triangle, that is ACD. We know that angle CAD at the top of this right-angled triangle is 30 degrees. and the base of this right angle triangle is again half of the side of the square, that is 7.5 centimeters. We are going to use the tangent function tan of the angle CAD equals CD over AC. Now we substitute the values we know, so tangent of 30 degrees equals 7.5 over AC. Therefore, AC equals 7.5 divided by tangent of 30 degrees, and that gives us 12.99 centimeters. We can now use Pythagoras' theorem in triangle ABC. So the height h of the pyramid equals square root of 12.99 squared minus 7.5 squared, and that is 10.6 centimeters. So the answer we are after is option B. Question 6. The shortest great circle distance between the Great Pyramid of Giza and the North Pole is approximately 6,702 kilometers. Assume that the radius of Earth is 6,400 kilometers. What is the latitude of the Great Pyramid of Giza? We need to calculate the angle of the center of Earth, theta, between the Great Pyramid of Giza and the North Pole. The shortest great circle distance between the Great Pyramid of Giza and the North Pole is 6,702, and this equals the radius of Earth, 6,400, times pi, all divided by 180 times theta. We solve this equation for theta, and we have theta equals 60 degrees. Now we need the latitude. The latitude is the angle from the equator. That is 90 degrees minus 60 degrees equals 30 degrees. The latitude of the Great Pyramid of Giza is 30 degrees north. Therefore, the answer we're after is option A. Question 7. A triangle KLM is shown in the diagram below. Point J is located on the side KM. The length of the side KL is 20 centimeters. The length of the sides JL and LM is 14 centimeters, and the angle LKM is 30 degrees. The question is asking for the size of angle JLM. We are going to use the sine rule in triangle KLM. That is KL over sine of angle KML equals LM over sine of angle LKM equals KM over sine of angle KLM. Now let's substitute the values we know. We know that KL equals 20 and LM equals 14. We also know that angle LKM is 30 degrees. From the first two fractions, we can write that sine of angle KML equals 20 times sine 30 degrees, all divided by 14. And that gives us 0.7143. So angle KML equals 45.58 degrees. Since triangle LJM is an isosceles triangle, angle LJM and angle KML are equal and equal to 45.58 degrees. Therefore, angle JLM equals 180 degrees minus 2 times 45.58 degrees, that is approximately 89 degrees. So the answer we are after is option D. Question 8. 3 friends will travel to Pepite, 18 degrees south, 150 degrees west, from different cities for a wedding in June. The friends, the city each friend is traveling from, name and coordinates, and their flight details are shown in the table below. The question is asking the order in which the friends will arrive in Pepite, from the first to arrive to the last to arrive. We are going to start with Harry, who travels from Tokyo on a longitude of 140 degrees east to Pepite, which is 150 degrees west. The difference between these two places is 140 plus 150 equals 290 degrees. We divide this by 15 and that gives us a time difference of approximately 19 hours and 20 minutes. So Pepit is 19 hours and 20 minutes behind Tokyo. Harry leaves on Monday at 5 p.m. So Monday 5 p.m. in Tokyo is Sunday 9:40 p.m. in Pepit. We have to add the 12 hours flight and that gives us 9:40 a.m. on Monday. So Harry arrives in Pepit at 9:40 a.m. on Monday. Now Josh starts from Auckland, which is on a longitude of 175 degrees east. So the difference between Auckland and Pepit is 150 degrees plus 175 degrees equals 325 degrees. We divide this by 15. So the time difference between these two places is 21 hours and 42 minutes. Pepit is 21 hours and 42 minutes behind Auckland. So Monday 10 a.m. when Josh leaves Auckland is Sunday 12:18 p.m. in Pepit. We have to add the 5 hours flight, which means that Josh arrives in Pepit at 5:18 p.m. on Sunday. Michael travels from Los Angeles on a longitude of 118 degrees west to Pepit. The difference between these two places is 150 degrees minus 118 degrees equals 32 degrees. We subtracted here the longitudes because they are on the same side, they are both west. So 32 degrees divided by 15 equals approximately 2 hours and 6 minutes. So Pepit is 2 hours and 6 minutes behind Los Angeles. Michael leaves on Monday 5 p.m. from Los Angeles, which is Monday 2:54 p.m. in Pepit. We have to add the 8 hours flight, and that is 10:54 p.m. on Monday. So Michael arrives at 10:54 p.m. on Monday. So the first one to arrive is Josh, the second to arrive is Harry, and the third to arrive is Michael. So the answer we're after is option E.